Hey there, Math 3 crew. This is Mr. NK. I just wanted to go over some of the problems that you were assigned during this break to help you out, maybe give you a little guidance. I know I can't be there with you hand in hand, having you write those homework questions up on the board, but maybe I can here. Now, as you entered into the new module, you haven't done any of the tasks. None of the homework that you're assigned actually has anything new to it. All of the homework that you're doing is a review of the stuff that you've done before. So, a lot of this will help you get ready for the new module because the new module has a great name. If we pull it up real quick and just look at the title of the module, it's modeling with functions. Big part of this is how do we use functions in real life? It turns out that most real-life equations are not as simple as one function. They actually combine tons of them together. And so that's what modeling with functions is all about. So a lot of this is review over previous functions. But once you've reviewed it, you're going to spend time putting your functions together. So all the work that you're doing is just review. So we're going to go over that. All right. So I've highlighted a problem in the ready, a problem in the set, and a few problems in the go that I wanted to go through with you just for you guys to judge whether you're doing it right, to get some support, anything like that. I know some of you might be a little too afraid to ask. So let's go ahead and read problem number 2 and find out what we're supposed to do first. First, we're doing the ready. It's reviewing transformations. So our job today is to review transformations. That's a transformation could be a translation. We could shift up, down, left, or right. Okay. It could be a rotation. Or it could be a reflection. Okay, so you have several different transformations here. Now, as we get to problem number 2, it says graph the following quadratic equations on the grid. So we're going to have to graph 5 different functions. The equation of y equals x squared has already been graphed for you. For each new equation, explain what the number 3 does to the graph of y equals x plus 2. Pay attention to the y-intercept, the x-intercept, and the rate of change. Identify what changes in the graph and what stays the same. So here are 5 different functions that we want to do. And in looking at them, before we even graph them, we may be able to know what happens. For example, if there's a plus or minus inside or outside the function, that develops into a specific type of change. And let's go through that real quick. Here, there's a x squared plus 3. You know the plus 3 is outside of the basic function, the x squared function. So that tells us we're going to shift this function up 3. Likewise, if you look at b, you're going to shift it down 3, because that negative takes the place of the plus. Okay? Oh, but what if the minus 3 is in the parentheses with the x? Take a second to think about that and write down what you think the transformation would be. Hopefully you wrote this down, that we want to shift it right 3. And we can tell that it's right because it's paired with the x. Anytime you have a number that's added or subtracted, it's paired with the x, or multiplied or divided, we know that we're going to be going left and right. Anytime something's paired with the x, we're also going to go the opposite direction. Okay, so this is x minus 3. Minus would usually indicate left because that's how you subtract on the x-axis, but we're doing the opposite, so we're going to go right 3. Likewise, take a second to write down the transformation that happens in D. All right, and you should have gotten down something similar to the previous one, but make this left 3. And last but not least, on E, we have 3x squared. Now notice the x squared is already there. The 3's not paired with x. So this isn't going to be a horizontal transformation. It's going to be vertical. Now when it's multiplied and divided, that isn't a shift up, down, left, or right. This is actually a stretch. Okay? All right, so we have our transformations written down. Now, as we go through this, I'm going to probably change the color of each of these. I'll start off with some light green for A. So let me go ahead and change that to light green. All right, so we're just going to take this function and shift it up 3. Not too hard. There's already points labeled, so you just want to shift it up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, and you should see that the graph looks like this. There you go. It shifted up 3. Now we've got the one that shifted down 3. Well, let me change this color to pink there. And we're going to shift the original function, not the green one, but the original function, down 3. 1, 2, 3. Right there. Down 3. 1, 2, 3. Right there. Right there. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. Booyah. So we've shifted it down 3. Now we're going to take that same function and do the other shift for C. And I'll use orange this time. Style orange. So we're going to shift it right 3. 1, 2, 3. Oh. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. Oh. Okay. So we got the transformation right. Now let's do the transformation left, and let's make that one brown. I never use the color brown. Right? I should say barely ever. So 1, 2, 3. And then up here, 1, 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. 1, 1, 2, 3. So we have it shifted left 3. And the last one is the stretch. Now, for a stretch, if you guys remember, and I'm just going to use the same color, this is a stretch by 3 vertically. You know, it's not paired with the x, so we know it's a vertical stretch of 3. Now, a pretty simple thing to do the vertical stretch is just to multiply the y value times 3. So right here, the y value is 0. So 3 times 0 is 0. So it's going to go there. Here, I have this new sensor that I learned. If you go to this spot and this spot, the y value is 1. So you think, what's 1 times 3? Oh, that's 3. So it's going to go up here at 3. Okay? And then we have this value of 4. Well, what is 4 times 3? That's 12. That's off the map. So we kind of have our graph already. It's just going to be real sharp. It'll look like that. And now we have all of them shifted in their right locations, and we have all of them graphed. Now, the last question that it tells us to look at is to identify what changes in the graph and what changes and what stays the same. So if we look at the one that was up 3, the green one, you'll notice something about each of our new green points. All the x values stay the same. This leads to that rule that the x values stay the same, the y values add 3. Okay? On the second one, the same thing is true, except it goes in the opposite direction. It's the y minus, not 1, 3. Okay? If we look at the third one, the orange one, as we move over, the new coordinates for some of these points, and I'm just going to label them, that's 3, 0. That is 5, 4? 1, 2, 3, 4. Yeah, 5, 4. One of the things you might notice is that the y values don't change this time. And so over here, the x values add 3, but the y values stay the same. Okay, and I do want to change the color of this one to match. Boom. All right, the one that goes left 3. Hopefully by now you've kind of gotten the pattern. X minus 3 and y. The x's change by 3, but the y's stay the same. Now with the stretch, this doesn't exactly happen in the same way. If we look at it, the x values are constantly staying the same. Here we've got 0, let me change colors again. Back to the dark blue. We've got 0, 0. Here we have 1, 3. So you notice how the x values stay the same, and the y value is changing, but it's not adding the same amount. It's being multiplied by the same amount. So that leads us to this rule, x, but 3 times y, because it's multiplying by 3 every time. There we go. My watch told me to breathe. Apparently I'm not doing that enough. All right, so if you have any further questions about this, about these different types of transformations, and how we can write them as these rules, you went over this in Math 1, hopefully a little bit before then too. But if you have any questions, don't hesitate to ask. Let's go on to the set homework. All right. The set encounters a lot of different functions. The first one, absolute value. The second one is exponential. The third one's quadratic and rational functions. But I figured the one that you guys would have the most trouble with is the log functions. Okay, so we want to graph the log function. And an easy way to graph a log function is to get 2 main points, the anchor point and the base point. Now, the base point is what happens when you plug in 1. So for k of x, if I plug in 1 for k, or for x, that becomes k of 1 equals log of 1. Now, if you guys remember back from Module 2, log of 1, anytime your input to your log is 1, it's actually 0. So our base point here is 1, 0. Well, that's good. And then we also wanted an anchor point. Oh, I'm sorry, I am saying that wrong. This is our anchor point. And we want to find the base point next. The base is, in a basic function, just the base of the log. You notice how there's nothing written below this log? There's no base written, so that is a base of 10. And the x is our input. Okay, so what input would give the output to be, or if your input was the same as your base, if x was 10, what would y be? And if you remember back in logs, we found out that that would be 1. And this is our base point. Now, this graph is kind of a little annoying because you're not able to really get there. You're not able to get to 10, 1. But we can graph it with that expectation that once it gets to 10, it will hit 1. So our anchor point is right here. And if you remember about logs, it goes up, curves, and goes up slower and slower as it gets bigger. Okay? All right, so that's the graph of our original function. What would happen if we added a -1 to that? Well, it's the same thing that happened up above. That -1 shifts this function down 1. Now, just to get a good contrast, I'm going to use not purple. Purple's not bright enough. I'm going to use pink here. Trying to use more colors, especially now that, we're not actively in a lesson in class. Hopefully it's helping you out. So this is the same function, it's just shifted down 1, which means our anchor point will be down 1 from our original anchor point. That's our new anchor. And the base point would be shifted down 1, so it would be, somewhere over there. All right, well, with that, we could go ahead and graph it. And that's what our anchor and base points look like with the shifts. All right, with each of the other ones, you want to do the same thing. Number 8 is something that we did in the last module. One of the things that you could remember to help you with number 8 is the cap. P8 or HP. The H is silent. All right. Uh-oh. Looks like my computer froze up. Boom. Well, let me just exit out of here and restart it real quick. All right. Sorry about that. All right. KAHP. Cap. And that cap stands for the vertical shifts, the amplitude, the horizontal shifts, and the P is the period. Remember, whenever you have a period, you have to take 2 pi and divide it by the number. All right, now we got 3 problems to work on here, and this is a pretty simple process. If you look up at the top, and let's do that right now. It's always good to read the instructions before you try and dive into a problem. Find the function values f of -2, f of 0, f of 1, and f of 3. Indicate if it's undefined for the given value of x. So we just got to find each of those. Let's go ahead and do it. F of -2. Well, if we look here, all we got to do is plug in a -2 and a -2 inside the absolute value. Now, absolute value really is distance from 0, so a -2 is 2 units from 0, just in the negative direction. So that -2 is really going to simplify down to 2 when you take its absolute value. So this becomes -4, because -2 times 2 is 4. All right, pretty simple so far. What about f of 0? I'm going to change colors here. Let's go to blue. F of 0 is equal to, well, 0 times the absolute value of 0. Well, if we look at that, what's the absolute value of 0? How far from 0 is 0? And if you did your math right, you should know that it's 0. This becomes 0 times 0, which is 0. Next, we've got f of 1, which is equal to 1 times the absolute value of 1. And the absolute value of 1 is 1, so it becomes 1 times 1, which is 1. Not too difficult. And last but not least, oh gosh, what color should I choose? Let's do gray. I never use gray. F of 3. F of 3 is equal to 3 times the absolute value of 3. Well, absolute value of 3 is 3 because it's 3 units away from 0. And we get 3 times 3, which is 9. 11 is all done. We've gotten each of these values. Now, one last check we want to make is we want to indicate if the function is undefined for given value of x. For each of the x's that we plugged in, the function is defined. So there's no undefined values here. Okay? Go to number 17, and we're going to go through that whole process again. F of negative 2. Well, that equals, and a good idea whenever you're working on these problems is just to plug it in and see what simplifies. Negative 2 over negative 2 plus 2 minus 5, which becomes negative 2 over 0 minus 5, which simplifies down to, wait a second, I'm dividing by 0. Can you divide by 0? No, this is undefined. All right, well, that's good. We got that one. Let's try f of 0. F of 0 equals 0 over 0 plus 2 minus 5, which is equal to 0 over 2 minus 5, which is equal to negative 5. Oh, no. Oh, cool. It didn't freeze up this time. Maybe it's just not registering my fingers. Okay, and next we've got f of 1. So that becomes 1 over 1 plus 2 minus 5, which is equal to 1/3 minus 5, which becomes 1/3 minus 15/3, which is negative 14/3. And that's our answer. Finally, we've got f of 3. With f of 3, again, just like before, you just plug that value in. So we get 3 over 3 plus 2 minus 5, which is equal to 3/5 minus 25/5, which is equal to negative 22/5. All right, number 18. Log base 3 of x. So, again, we want to do f of negative 2 equals log base 3 of negative 2. Well, if your input is negative, is there any power of 3 that gives you a negative answer? Because logs are just inverse exponential functions. What this log base 3 of negative 2 really means is 3 to some power 3 to some power f of x equals negative 2. What power of 3 gives you a negative number? And once again, this is going to be undefined. Okay. Next. Oh, I used the wrong color there. Okay, so now what about f of 0? That's log base 3 of 0 equals, well, whenever we think about this one, what power of 3 would give you 0? Take a second. 3 to what power gives you 0? Hopefully your answer was none. So this, just like the previous answer, is undefined. Okay. Now let's try the next one. F of 1 becomes log base 3 of 1. And as we talked about just a few minutes ago, if the input of a log is 1, the output will always be 0. Okay? And then finally, f of 3. F of 3 is equal to log base 3 of 3. So what power of 3 produces the number 3? Well, 3 to the first power gives you 3. So in this case, we've got all 4 of our answers, and we've indicated the undefined ones. And hopefully you saw why they would be undefined. Okay? In one case, we're dividing by 0. The other one, you can't take a log of a negative number. And the last one, you can't take a log of 0. Those are some basic math rules. All right, with that taken care of, I hope you'll ask me any questions online in Google Classroom. If not, and you have questions, please let me know. I'm going to bring this video to a close. Take a look at the work that we've done. Yay! Yay, Mickey! All right, one more thing. In the future, we might be doing some online courses. I'm not exactly sure how that's going to operate, whether we'll do a mixture of Zoom and YouTube videos. I'm just learning how to use YouTube right now to upload my own videos regularly, and just learned how to use it on my iPad as well. All right, with that said, I'm going to